Chapter 7 is all about tessellations. We're actually going to be doing a tessellation project in this unit. We're just going to go through a few vocabulary words just to get started. I would recommend writing these down on a separate sheet of paper just so you have them in case you're confused by anything. We're just going to spend a few days on this unit. It's not anything that's going to be tested, but you are doing a project on it. So the first term is translation, okay? Translation is kind of like shifting, okay? So like shifting something to the left or to the right, okay? Or up or down or diagonally, okay? I know a lot of you have translated things. Maybe you guys talked about translation, rotation, and reflection when we're dealing in elementary school. So kind of the same concept. Okay, just the definition is a little more complicated in geometry. It's not something that you need to like exactly memorize, but where all the points move the same distance along a parallel path to form the image. Okay, so the image stays the same. Every point and every part of the figure is being shifted the same distance. Rotation. A rotation is where all the points of the original turn, where all the points of the original turn a certain number of degrees in one direction. Okay, so everything is going to shift 60 degrees, okay, or everything is going to shift 90 degrees or 180. Okay, so rotation is all those points are turning a certain number of degrees. Reflection. Reflection is producing a mirror image of another object or of the object. So during our tessellation unit, we are actually going to be talking about, we're going to do a translation tessellation and a rotation tessellation. We will not be doing the reflection one. Okay, but those are three different types of tessellations. So what is a tessellation? A tessellation completely covers a plane without gaps or overlap. Okay, it's kind of like tiling. Like look at the tile on the classroom floor. That is a tessellation, or the bricks on the wall, or the squares on the ceiling. Those are all a tessellating pattern. Okay, typically when we think of tessellations, they're pretty, they're colorful. Okay, but as long as there's no gaps or overlaps and everything fits together nicely, okay, that would be a tessellation. So there are a couple of shapes that tessellate and a couple of shapes that do not tessellate. Okay, so obviously squares, okay, for example, the tile on the floor, or the tile in your house, okay, fits together nicely, okay, it tessellates. Also, a hexagon, okay, hexagons tessellate nicely, they're all fit together. If you think of like a honeycomb, okay, like a bee's nest, you know, like all that with the honeycomb, or like a soccer ball, you'll see hexagons, they all fit together nicely. And then also triangles, okay, triangles fit together nicely as well. Okay, if you notice, actually 6 triangles fit together to form a hexagon. Okay, so that's a reason triangles also tessellate. Okay, notice the pentagons. Okay, I put 3 of them together there, and there's a little gap in it. So pentagons, they would not tessellate. Now, we got to think about, why do squares, triangles, and hexagons tessellate? It's because of their angles. Okay, their angles all form together at 360 degrees. Okay, so thinking about squares. Okay, we have 4 squares, they tessellate together because we got 90, 90, 90, 90. They form 360 degrees. Okay, same with triangles. Let's see if I can draw this. Decent. Okay, 60 degrees plus 60 plus 60 plus 60 plus 60 plus 60 equals 360 degrees. Same with a hexagon. Okay, 120, 120, 120, if they all fit together. So their angles form at 360 degrees. Okay, so Would a regular octagon tessellate? No, it would not. Okay, but an octagon could tessellate with another shape. Okay, so other shapes could tessellate together. So notice here we have um, a dodecagon with some triangles to help fill in the gaps. Okay, so those would tessellate. Obviously, a dodecagon would not tessellate by itself. Okay, but together with a triangle, they would form a nice tessellation. Octagon and a square, notice that those would tessellate together. So an octagon by itself, we couldn't make it fit, okay? But with a square, it kind of helps finish that 360 degrees. Here are some more examples of some tessellations using squares, hexagons, and triangles. They tend to be our base of our tessellations. So looking at these figures, okay, thinking about, well, what's the base used to create these tessellations? So we'll start with like the cat-like thing up here. Okay, looking at it, what would be the base? Would it be a triangle? Would it be a square or a hexagon? Hopefully you noticed that it kind of looks like a hexagon there, right? Okay, we see all like the points there. Okay, looking at the dog, hopefully you said square. Looking at the bottom two, very similar because they are both with a hexagon. You can see like the bat wing has like those lines. Okay, you are going to be creating your own tessellation using a square, a triangle, or a hexagon. In your book, you have a few patterns laid out for you. If that's something that you are interested in, you can go and look to chapter 7. There are some where it gives you kind of a step-by-step if you're looking for a certain shape or a certain figure. So here we have kind of like a Pegasus going on. So if you're interested in that, you could look at that. Here we have kind of a bat type shape using translation with a hexagon. Okay, so you could look at that if that's something. Here we have a bird or a fish, depending on how you look at it, using rotation with a triangle. And then there is kind of a lizard type thing on page 403 if that's something you're interested in. Okay, so you will be creating your own. There are videos created for you to watch and practice. And then you will choose one of those, the ones you practice on. You'll choose one to create a final product. Okay, so you are going to do some practicing for this next day or two, and then you're going to complete your final project.